Welcome back, dear students. So as you all know that we are doing integration by partial fraction. Okay, so this is my second part of the video on the same, that is partial fractions. So the first question for you is on this screen right now, which says that if this is my integral I, then find the value of this integral. Okay, so if you remember, or if you observe here, you see that the numerator's degree is x to the power 4 because you get x square into x square is x to the power 4, and in the denominator also you have got the same, right? Okay, so what you need to do here is, first you will multiply the numerator and denominator. Okay, so if I do that, so we get x to the power 4 plus, okay, so I think you'll get 3x square plus 2 in the numerator. Similarly, in the denominator, you get x to the power 4 plus 7x square plus 12 dx. So you clearly see that the degree of numerator is 4 and the degree of denominator is also 4. So in this case, what do you need to do? You need to divide, isn't it? So you all know that. Now, if you want to do division, that is also fine, or else if you want to just do or some manipulation, that's also fine. Okay, so let me divide it for you. So when you divide here, you have, okay, so x to the power 4, x to the power 4 plus 7x square plus 2. So when you divide by this to the numerator, that is x square, x to the power 4 plus 3x square plus 2, then you will get, okay, so first is x to the power 4, so you will multiply only once, isn't it? So you get x to the power 4 plus 7x square plus 2, isn't it? Yes, this is 12. Just wait, this is 12. So you'll get 12 out here. Okay, so minus minus minus, so these two gets cancelled, so you get minus 4x square. So 12 minus 2 is minus 10. So this is your remainder. And as I gave you one formula yesterday, that dividend can be written as divisor into quotient plus remainder. All of you know this formula, isn't it? Okay, so in that case, this becomes, okay, so this is your divisor, remember. So this is your dividend. So dividend is numerator. So this numerator can be written as dividend. So what is dividend? Divisor. Divisor is this. So this can be written as, numerator can be written as divisor. So divisor is x to the power 4 plus 7x square plus 12 into quotient. Quotient is how much? Quotient is 1. So 1 plus remainder. Remainder is this much, isn't it? So plus remainder means 4x square minus 10 divided by x square plus 7, x to the power 4 plus 7x square plus 12, and we have got dx also. Okay, so we have, see here carefully, x to the power 4, that is this, into 1 is x to the power 4 plus 7x square plus 12 itself, divided by, we have got x to the power 4 plus 7x square plus 12 dx, right? And you have here minus 2 can be kept common, isn't it? So minus 2 is constant, will be kept outside, so you get 2x square plus 5 divided by x to the power 4, okay, so let me write this, x to the power 4 plus 7x square plus 12 dx. Okay, so these two gets cancelled, so you get integral dx minus 2. Okay, so this is 2x to the power 2 plus 2. Now as you all know, x to the power 4, that is this full thing, is what? This, isn't it? That is x square plus 3 into x square plus 4 dx. Now all of you know that this is integral dx is x minus 2. Now this, okay, here you can apply integration using partial fraction. Okay, so let me call this entire integral to be I1. Okay, now see, This falls under first category of integration using partial fraction. You have already seen this, isn't it? So we take, let x is 2x square plus 5, plus 5 divided by x square plus 3 into x square plus 4 equals to a by x square plus 3 plus b by x square plus 4. Okay, so from here you just need to calculate the value of a and b, isn't it? So this turns out to be, okay, so LCM is x square plus 3 into x square plus 4. So this becomes a into x square plus 4 plus b into x square plus 3, right? So this becomes, so this is a plus b x square plus 4a plus 3b divided by x square plus 3 into x square plus 4. Now you see that denominators are same, so when you compare both sides, you get the quotient of x square is a plus b. So a plus b turns out to be, what is the quotient of x square here? It is 2, isn't it? So call this as equation 1. And we have 4a plus 3b, that is a constant term, will be equals to 5. Okay, call this as equation 2. So solve 1 and 2 and find the value of a and b. So you may pause the video and note it down. Okay, so when you solve a and b, that is solving 1 and 2. Solving 1 and 2 gives you a equals to -1 and b equals to 3. Okay, so please do this part by yourself. So therefore, now see, we have integral I is equals to x minus 2i1, isn't it? So I1 is integral. So all of you know that we have this part. I1 is this one, isn't it? And this part is actually this much, isn't it? So instead of this, I'm writing this now. Okay, so if I do that, then I can write this integral as a by x square plus 3 plus b by x square plus 4. Okay, and we have got dx. Now this integral can be written as x minus 2. Okay, so we have a integral dx by x square plus 3 is there, right? So this 3 can be written as root 3 square. Okay, plus we have b can be kept outside, so b integral dx by x square plus 2 square. Okay. Okay, so let me close the bracket out here. So now you know that, okay, so let me first put the value of a. Okay, so as you all know that a is -1, so this becomes x. Okay, so this is -1, so you can just write minus. Now this integral is there, isn't it? So this integral is equal to 1 by a is root 3 tan inverse. Okay, so tan inverse x by a, so x by a is this much. Okay, fine. So we have plus, what is b? B is 3. So again you have to apply the same formula. So this becomes 1 by a is 2 in this case, so this becomes tan inverse x by a, that is 2. Okay, with a constant of integration. Okay, so if you want to open up the bracket by multiplication with -2, that will be okay for you. So this becomes minus into minus is plus, so 2 by root 3 tan inverse x by root 3. Okay, minus 2 and 2 gets cancelled. See, minus into plus is minus, 2 and 2 gets cancelled, so you get only 3 here. So 3 tan inverse x by 2 with constant of integration. Okay, so your answer for this particular question turns out to be this much. So you may pause the video and note it down. Now dear students, we'll see a different kind of sum here. Okay, so if you remember this sheet in front of you, we have seen many problems of the first kind, but we haven't seen the remaining 4, isn't it? So we'll try to cover each of them in today's class. So if you see this question contains whole square where you have got a linear thing, isn't it? So this is a linear expression with whole square. So here also we have got a linear with a square, isn't it? So as per this rule, we have to take this entire thing, that is this, to be equals to this much. Okay, so let's apply then. So we have to take, okay, so this is your I, so you will take 3x minus 1 by x plus 2 whole square as a by, first you will write only once x plus 2, then later on you will write the same thing twice, that is x plus 2 whole square. Okay, so as usual your rule is same, so you get 3x minus 1 x plus 2 whole square, so your LCM is again x plus 2 whole square. So divide this LCM by x plus 2, you will get x plus 2, so you get a into x plus 2 plus you will write b here. Okay, so from here you get 3x minus 1 by x plus 2 whole square is equal to, so this will be ax plus 2a plus b, so the constant term is kept within a bracket, so you have x plus 2 whole square. So therefore, by comparing, the coefficient of x here is a and the coefficient of x here is 3, so the value of a turns out to be 3, and the constant term, that is 2a plus b, will be equals to minus 1. Now what's the value of a? A is 3, so this becomes 2 into 3 plus b is equals to minus 1. So this is 2 into 3 is 6, so the value of b turns out to be, so minus 1 is there, this goes over there, becomes minus 6. So altogether you will get minus 7. Okay, so the value of b is also known to us. Therefore, your integral I can be written as integral, so this can be written as a into x plus, a by x plus 2 plus b by x plus 2 whole square dx. So let me keep this a outside, so this can be written as a integral dx by x plus 2 plus this b can be kept outside, so this can be written as dx by x plus 2 whole square. Okay, so okay, first let's do substitution here. Okay, so let me write, let x plus 2 is equals to t. Okay, so from here what do you get? You get dx equals to dt, isn't it? So therefore your integral I will change into a integral, so dx is dt, so dt by t plus b, and in the same way we have dx by, this is t, so this becomes t square. Okay, and the value of a is 3, remember, and this becomes log t plus b is how much? B is minus 7. Okay, and this is t to the power minus 2, isn't it? So integral of t to the power minus 2 will t to the power minus 2 plus 1 divided by minus 2 plus 1 with constant of integration. So this will be 3 log t, so this is minus 1, remember, so minus 1 into minus 7 becomes plus 7, so this is t to the power minus 1, which can be written as 1 by t with constant of integration. Now let's resubstitute the value of t. So what is t? T is x plus 2, isn't it? So that's why this can be written as 3 log x plus 2 plus 7 by t, that is 7 by x plus 2 with constant of integration. So you may pause the video and note it down. Okay, so now if you look at this one, this falls under your third category, because as you can clearly see that the third one contains in the denominator 3 linear factors. Here also we have got 3 linear factors, isn't it? So okay, so let me show you the rule here. So the rule says that See, if the factors are not repeating, then you can write this thing like the first one, okay, but you have to put one more extra term, okay. So if you have understood that, so let me write this as integral I, and you can write this I, you know, this 3x minus 1 divided by x minus 1 into x minus 2 into x minus 3 as a by x minus 1 plus b by x minus 2 plus c by x minus 3. See, you always need to look at the denominator, okay, no need to worry about the numerator. So this becomes, so 3x minus 1 is there, so in the denominator x minus 1 into x minus 2 into x minus 3. Okay, so here the LCM is x minus 1 x minus 2 into x minus 3. Okay, so as usual, do this simplification, divide this denominator, this LCM by denominator, x minus 1 will be vanished, so you will get only this part. So you get a into x minus 2 into x minus 3 plus we have b. Similarly, x minus 2 and x minus 2 gets vanished, so you get x minus 1 into x minus 3. Okay, similarly we have got plus c, and x minus 3 gets vanished, so you get x minus 1 into x minus 3. Okay, so let me just simplify this part. Okay, so this becomes a into, this is x square minus 5x plus 6 plus b into, this becomes x square minus 4x plus 3, and the last one becomes x square minus 4x plus just wait a minute. Okay, I'm sorry, this is 2. Okay, so this becomes 3x plus 2, okay, divided by the same quantity x minus 1 into x minus 2 into x minus 3. Okay, so here you get, okay, so a plus b plus c into x square, that's what you get. Okay, now the coefficient of x will be, see here carefully, it will be minus, okay, let me write as plus, so you get minus 5a from this, from here you get minus 4b, okay, and from here you get minus 3cx. Okay, and the constant term that you find here is 6a plus 3b, so this is 3b plus 2c by x minus 1 into x minus 2 into x minus 3. Okay, now compare both sides. See, denominators are same. Okay, so you need not worry about denominator. Look at the numerator. Now what is the coefficient of x square here? It is this much. Now do we have x square here? So we don't have here. So when you compare both sides, so comparing, you get, see here carefully, coefficient of x square, that is a plus b plus c will be equals to 0, because we don't have any x square quantity here. Call this as equation 1. Now coefficient of x here is this one, isn't it? That is minus 5a minus 4b minus 3c, and the coefficient of x here is 3, isn't it? So that's why we have this as equation 2, and the constant term here is 6a plus 3b plus 2c equals to, now what is the constant term here? It is minus 1, so this becomes minus 1, and this is my equation number 3. Okay, so from here, from these three equations 1, 2 and 3, what you need to do is use these two. Okay, use these two and eliminate one of the variable. Use these two and eliminate one of the variable. Okay, and solve. Okay, so let's see the first part. Okay, so I'm going to eliminate any one of the variable here. So for that, let me multiply 1 by 5 and add with equation 2. Okay, so multiply equation 1 by 5. So let's see how much do we get. So we get 5a plus 5b plus 5c is equals to 5 into 0 is 0. And since you are adding with 2, 2 is minus 5a minus 4b minus 3c equals to 3. Now since you are adding, we need not change any sign, so these two gets cancelled. So you get 5b minus 4b is b plus 5c minus 3c is 2c is equals to 0 plus 3 is 3. So call this as equation number 4. So same thing you are going to do with 2 and 3. Okay, so what you can do here is, okay, let's make use of not 2 and 3, let's make use of 1 and 3. So same thing I'm going to do here. Okay, so what am I going to do here is, I'm going to multiply 1 by 6. Okay, because we have got 6 here, no? So multiply with 6 and then subtract 3. Okay, then subtract 3. So let's see how much do we get. So multiply 1 with 6, you get 6a plus 6b plus 6c. So you have got minus 3. 3 is this one, isn't it? So all the sign will get reversed. So this becomes minus 6a minus 3b minus 2c is equal to, so in the left hand side we have, I'm sorry, right hand side we have 0 minus of minus 1. See, 6 into 0 is 0 minus we have minus 1. So this means, see here carefully, 6a and 6a gets cancelled. 6b minus 3b is 3b. Okay, 6c minus 2c is 4c is equals to 1, isn't it? So let me call this to be equation number 5. So I don't have a space here, so you may pause it and note it down. Now you have two equations, remember. Okay, so we have equation 4 and 5. We need to solve it. So multiply this with 3 and multiply this with 1. Okay, so from here you get 3b plus 2 into 3 is 6, c is equals to 3 into 3 is 9. So this will remain as it is. So 3b plus 4c equals to 1, subtract. Okay, so these two gets vanished. 6c minus 4c becomes 2c equals to 9 minus 1 becomes 8. So from here you get the value of c equals to 4. Okay, so substitute the value of c in 4. So from 4, so from 4 you get b plus 2c. c is how much? 4 is equals to 3. So this is b plus 8 is equals to 3. So from here calculate the value of b. It turns out to be minus 5. Okay, now you remember we have equation number 1. Okay, so from equation 1, see, in equation 1 we have a plus b plus c equals to 0. So we have a plus b, b is minus 5, plus c, c is 4 is equal to 0. So from here you get a minus 5 plus 4 is equal to 0. That is a minus 1 is 0. So from here you get the value of a is equals to 1. Okay, so we got the values of all the unknowns, isn't it? So let's go back to our work. So we need to calculate what is our integral I, isn't it? So integral I turns out to be, so you remember you had 3x minus 1 whole divided by x minus 1 into x minus 2 into x minus 3. That can be written as a by x minus 1 plus b by x minus 2 plus c by x minus 3 dx. So as you all know, this can be written as this much plus b dx by minus 2 plus c integral dx by x minus 3. Okay, so all of you can see that the coefficient of x here is plus 1. Here also it is plus 1. Here also it is plus 1. So we can directly write down the formula value or formula. So a is 1, isn't it? So this becomes 1, and the formula of this becomes log of x minus 1 plus, okay, so this becomes b. B is how much? B is minus 5. Okay, so this becomes log of x minus 2. And what is c? C is 4. So this becomes plus 4 into log of x minus 3 with constant of integration. So let's simplify this further. So this becomes log of x minus 1 minus 5 log x minus 2 plus 4 log x minus 3 with constant of integration. So this is my answer for this particular question. So you may pause it and note it down. Okay, so again, this integral falls under the same category. You know why? Because this can be written as, see here carefully, this can be written as 5x dx by x minus 1, x plus 1 into this x square minus 4 can be written as x minus 2 into x plus 2. Yes, so in this case again you have to take this entire thing, that is 5x by x plus 1 into x minus 2 into x plus 2 equals to a by x plus 1 plus b by x minus 2 plus c by x plus 2. Okay, so as per the rule we'll go in the same manner. So we have x plus 1 into x minus 2 into x plus 2 here. Okay, so you know that this becomes x into x minus 2 into x plus 2 plus b into x plus 1 into x plus 2 plus c into x plus 1 into x minus 2. Okay, so multiply, so you get x square minus 4 plus b into x square plus 3x plus 2 plus c into x square minus x minus 2. Okay, divided by the same quantity x plus 1 into x minus 2 into x plus 2. Now let's see what is the coefficient of x square. So it becomes a, from here you get plus b, and from here you get plus c. So this is your x square. Now plus we have the quotient of x, so from here minus 4a, minus 4a is just a constant, so from here we get 3b, isn't it? So this is 3b plus from here you get c into minus 1 is minus c. Okay, x, and the remaining things are minus 4a, so from here you get plus 2b, and from here you get minus 2c, isn't it? Divided by x plus 1 into x minus 2 into x plus 2. So comparing, so as usual comparing, see here carefully. So you have the quotient of x square is this one. We don't have x square here, so that's why this becomes a plus b plus c is equal to 0. Call this as equation number 1. So you have the quotient of x here is 3b minus c. So 3b minus c turns out to be equal to the quotient of x here is 5. Okay, 2, and we don't have any constant term, isn't it? So that's why you get minus 4a plus 2b minus 2c is equal to, we don't have any constant term, so that's why this becomes equals to 0. Call this to be equation number 3. Okay, so if you refer to your earlier problem, there we had removed one of the variable from two equations, isn't it? So the same thing can be done if I use equation 1 and 3. We need not do anything with equation number 2 because we don't have 3 variables here. Okay, so in order to remove one variable from 2 and 3, let's multiply 1 by 4 and add it with equation number 3. So if I do that, then I'll get 4 into 1. Okay, so you get 4a plus 4b plus 4c is equal to 0, and you have 3 is 4a plus 2b minus 2c is equals to 0. So add it. Whenever you are adding, you need not change the sign. So these two gets vanished, so you get 6b here plus you get 2c here equals to 0. So divide both sides by 2 because 2 is common. So from here you get what? 3b plus c is equal to 0. So call this as equation number 3. Let me call this as equation number 4. Okay, now in order to solve 2 and 4, you just need to add. Okay, because adding 2 and 4 gives you, let's see how much do we get. So 2 is 3b minus c plus 4 is 3b plus c equals to, so we have 5 plus we have got 0 here. So c and c gets cancelled. So 6b is equals to 5 plus 0 is 5. So the value of b turns out to be 5/6. Okay, so we got the value of b. Now it's our job to find the value of c using, okay, so let's use equation 4. So from 4 you have 3b. So 3 into b is 5/6 plus c is equal to 0. So 3, 2, so you get the value of c to be minus 5/2, isn't it? Okay, now let's make use of equation 1 in order to find the value of a. So from 1 you get a plus b. B is how much? B is 5/6 plus c. C is minus 5/2 equals to 0, right? So from here you get the value of a to be equals to 5/2 minus 5/6. So the LCM, okay, so let me directly write down the value for you. So it's going to be 6. Okay, so this is going to be 10/6. Yes, so it's going to be 10/6, which is 5/3. Okay, so we got the value of a also, which is 5/3. Okay, so you may pause the video and note down till here. Okay, so forget about this we have done earlier. Okay, so if you see the value of a is 5/3, b is 5/6 and c is minus 5/2. So your integral I will turn into this, which can be written as a is 5/3 integral dx by x plus 1 plus this b is 5/6 integral dx by x minus 2 plus c is minus 5/2 integral dx by x plus 2. Yes, so this becomes 5/3 log of x plus 1 plus 5/6 log of x minus 2 minus 5/2 log of x plus 2 with constant of integration. Okay, so this is my answer for this particular question. So you may pause the video and note it down. Okay, so in order to do this, let's see whether we can factorize the denominator or not. So can we factorize this part? No, right? So if you cannot factorize this, then let's see our sheet. So from the sheet I can see that this falls under the last category, because the last one, this is the quadratic part, isn't it? So this quadratic part cannot be factorized. So whenever this cannot be factorized, this can be written in this way. Okay, so if I write this in this way, we get, okay, so let me call this to be integral I. So you can write this as x by x square plus 1 into x minus 1 as, okay, so the rule says a by the linear part. Which one is linear? Linear is x minus 1 plus bx plus c by the one which cannot be factorized, which is x square plus 1. Okay, now let's simplify this. So this can be written as x minus 1 into x square plus 1. So you get a into x square plus 1 plus bx plus c into x minus 1. So let's quickly simplify this. So you get ax square plus a plus this becomes bx square minus bx plus cx minus c by x square plus 1 into x minus 1 in the denominator. Okay, so the coefficient of x square becomes a plus b. Yes. Okay, now the term containing x are c and b only, isn't it? So that's why this becomes c minus b x. Okay, and the constant term is a minus c divided by x square plus 1 into x minus 1. Now again let's compare. So comparing, what is the coefficient of x square? It is a plus b. And do we have x square? No. So that's why we'll write it as 0. Call this as equation 1. Okay, now the coefficient of x is c minus b. And do we have x here? Yes. So what is the coefficient of x? It is 1. So this 2. So we have a minus c, so the constant term. Do we have any constant here? No. So that's why this is equal to 0. So let me call this as equation number 3. Okay, so what you can do here is let's add 1 and 3. Okay, so adding 1 and 3, let's see how much do we get. So we have a plus b plus c minus b is equals to 0 plus 1. So here minus b gets cancelled. So the value of a plus c turns out to be 0 plus 1, which is 1. So let me call this to be equation 4. Now let's add 3 and 4. Okay, so adding 3 and 4. Okay, so adding 3 and 4. So let's see how much do we get. So 3 is a minus c plus 4 is a plus c. Will give you 0 plus 1, isn't it? So 0 plus 1, you see that these two gets cancelled. So from here 2a turns out to be equals to 1, and from here a turns out to be half, right? So this is the value of a. In order to calculate the value of b, you can use 1. So from 1 a, that is half, plus b turns out to be 0, which gives you the value of b to be minus half. Okay, so this is the value of b. Now you need to calculate the value of c, isn't it? So the value of c can be calculated using 3. So from 3 you have a minus c. So a is half minus c is equals to 0, which gives you the value of c to be equals to half. Alright, so therefore your integral I, see here carefully, integral I can be written as integral, so this is there. Okay, so this thing can be written as a by x minus 1 plus bx plus c by x square plus 1 dx, isn't it? Okay, so let's do the needful here. So you see that a is a constant, so if I keep a constant outside, so this becomes dx by x minus 1 plus, so integral b. Okay, so let me put the value of b now. So b is minus half x. Let's put the value of x. A also, a is half, no? Okay, so plus c. C is how much? C is also half divided by x square plus 1 dx. Okay, so you see that, so half is there, so this can be written as log of x minus 1 minus half can be kept common. Okay, so this becomes x minus 1 by x square plus 1 dx. Okay, now see here carefully, this integral is there, isn't it? So this integral can be again separated, so it can be written as half log of x minus 1 minus half integral x by x square plus 1 dx. Okay, minus into minus becomes plus half of integral dx by this x square plus 1 can be written as 1 plus x square, right? Now see here carefully, this is integration using substitution. Okay, substitute the value of x square plus 1 equals to t, and you can work with this. Now you know what is the integral of this? This is tan inverse x. Okay, so I am leaving this work for you to complete by yourself. So do this by substitution and put the value of this to be tan inverse x and put a constant of integration. So you may pause the video and note it down. Okay, so in this question, now can I factorize the denominator? Because all of you know that we have to check whether the denominator can be factorized or not. So I see that it can be factorized. We see that x is common here, so x square is common, so it becomes x minus 1, and here if you take minus common, it becomes x minus 1. So in the numerator we have 3x plus 5 dx. Okay, so we have integral 3x plus 5. Okay, so this can be written as x minus 1 is common here now, so x minus 1, so you get x square minus 1, isn't it? Okay, dx is there, so this is integral 3x plus 5 x minus 1. Now see here carefully, this x minus 1 can be written as x minus 1 into x plus 1, isn't it? Yes. Now x minus 1 into x minus 1 becomes, so we have got x minus 1 into x minus 1 is x minus 1 whole square into x plus 1 dx, right? Okay, now let's compare this with the sheet that we have. This falls under this category, isn't it? So as per this rule, we have to write this as this. Okay, so let me write this as, let 3x plus 5 divided by x minus 1 whole square into x plus 1 as a by x minus 1 plus b by x minus 1 whole square plus c by the remaining factor, that is x plus 1. Okay, so LCM is x minus 1 whole square into x plus 1. Okay, so divide this LCM by x minus 1. How much do you get? You get a into x minus 1 into x plus 1. Yes, so we have got b into x plus 1, and you get c into x minus 1 whole square. Okay, let's open up the bracket. So you have x minus 1 whole square into x plus 1 in the denominator. So this becomes a into x square minus 1 plus this becomes, okay, so let me keep it as it is for now. Okay, and this becomes c into x square minus 2x plus 1. Okay, so that's why, see this carefully, we have this equal to, okay, so this can be written as, so first let's write the coefficient of x squared. So it is a, do we have x square here? No, so here we have c, so we get a plus c into x square. Okay, so let's write the quotient of x here. So do we have x here? No, we have x here, so this becomes b, and here the quotient of x is minus 2 into c, that is minus 2c x, and the remaining ones are minus a plus b, and from here you get plus c. So this is your constant term divided by, you have x minus 1 whole square into x plus 1. Now comparing, do we have x square here? No, we don't have x square, so that's why a plus c turns out to be 0. Call this as equation 1. Now, do we have the quotient of x here? Yes, so the quotient of x here is 3, and here it is b minus 2c. So the value of b minus 2c turns out to be 3, and let me call this as equation 2. Okay, and similarly we have the constant term. So the constant term here is 5, and here the constant term is minus a plus b plus c. So the value of this turns out to be equals to 5. call this as equation 3. Okay, so what am I going to do is adding 1 and 3, because I see here is plus a, here we have got minus a, so they'll get cancelled if I add them. So we have a plus c minus a plus b plus c is equal to, see here carefully, so this becomes 0 plus 5, isn't it? Okay, so minus a and this gets cancelled, so you get b plus 2c, isn't it? So b plus 2c turns out to be 5. So let me call this as equation number 4. Now I am going to add the remaining ones. So adding 4 and 2. Okay, so that is 2 and 4 gives me, okay, so let me write 2 first. So this is b minus 2c plus 4. 4 is b plus 2c. So this turns out to be 3 plus 5. Okay, these two gets cancelled. So from here 2b is equals to 3 plus 5 is 8. That is the value of b turns out to be 4. Okay, now if you want to calculate the value of a, okay, so let's calculate the value of, see, using b you can calculate the value of c using either 3 or 4. Okay, so from 4, let me use 4. So you have b, that is 4 plus 2c is equals to 5. So 4 goes over there, becomes 2c is equals to 5 minus 4, which is 1. So the value of c is equals to half. Okay, so now you can use 1. So from 1, value of a turns out to be, a is minus c, which is this much, isn't it? So we got the value of a, b and c. Okay, so you may pause the video and note down till here. Okay, so we have the values written out here, and your integral I will change into this. Okay, a is kept constant, so this becomes this much, plus b integral dx by x minus 1 whole square, plus c into integral dx by x plus 1, isn't it? Now you can use substitution out here. Okay, so let's do the substitution then. So let x minus 1 is equals to t. So from here you get dx is equals to dt. Okay, so therefore your integral I will change into a is minus half. This integral is easy, which is log of x minus t, x minus 1, plus b is 4. So this integral changes to dx is dt, and you know that x minus 1 is t, so this becomes t square, plus c is half, and this integral is log of x plus 1. Okay, so minus half log. Okay, so what you can do here is, so here also we have got half, here also we have got half. Take half common, you will get log of x plus 1 minus log of x minus 1. Okay, so this is plus 4. This is integral of t to the power minus 1, isn't it? So this becomes t to the power, integral of t to the power minus 2. So this becomes t to the power minus 2 plus 1 divided by minus 2 plus 1. Now put a constant of integration. So half, so this is log a minus b, right? Log a minus log b is log a by b. Okay, plus 4 into, this is t to the power minus 1. Yes, okay, so t to the power minus 1 by, this is also minus 1 with constant of integration. So half log of x plus 1 divided by x minus 1. Okay, so minus into plus becomes minus, so this becomes 4 by t, isn't it? And what is t? T is x minus 1 with constant of integration. So this will be my answer for this particular question. Okay, so these are my 2 last questions, and I'm not going to complete this. You will complete by yourself. So here first you have to do substitution. So let me take the substitution to be this one, equals to t. Now differentiate this, you will get n x to the power n minus 1 dx is equals to dt. Okay, now can I write this as n x to the power n dx by x? Can I do that? Yes. So this becomes dt. Now you know I need the value dx by x, and we have dx by x here, isn't it? So you know that x to the power n is t. So can I write this as nt dx by x? Yes. So we get this equals dt. So from here, what is dx by x? Dx by x turns out to be dt by nt. So if this is your integral I, your I will change into integral, see here carefully, dx by x is dt by nt. So n is a constant, will be kept outside integral sign. So this becomes dt by t. Now you have into x to the power n is t, so t plus 1. Okay, so after this, will you be able to do this? Definitely. So you can go with integration using partial fraction. So I'm going to do the same thing with this also. So let e to the power x is equals to t. So from here you get e to the power x dx will be dt. Okay, so e to the power x is t in fact. So t dx is equals to dt. So what is the value of dx? The value of dx turns out to be dt by t. Okay, so your integral, if this is your I, will change into, okay, so dx can be written as dt by t, and you have e to the power x is t, so t minus 1 you get. So again, both are of same kind, so use integration by partial fraction. So with this, we close integration using partial fraction. Thank you very much.